Hey, welcome back to Mr. P Helps with Algebra 2. This is Unit 6, Topic 1, SLT2. So we are determining the effects of mean and standard deviation on a normal distribution, which gets us towards looking at the empirical rule. So this is a left skewed, and you can tell based upon what I talked about in the last video that the tail is going to the left, which means that the mean is going to be less than the median. So think of it, this would be a normal distribution had these bars not been there, and these maybe been a little bit shorter. So think of those as outliers, and those outliers actually pull the mean down. Here, the mean is going to be the same as the median because this is pretty close to normal distribution. If it's not the same, it's going to be very, very close. This one is right skewed, which means that the mean is going to be above the mean. Or above the median. Sorry, the mean is going to be above the median. So, list of our key features. Remember, this is normal distribution. We talked about how it's bell-shaped in the last video. It's symmetrical on both sides. It's same mean, median mode. There's no outliers, and it's unimodal, which means that there's only one mode. There's only one peak in the middle. All right, so we are breaking this up into, so this is like the empirical rule, so we have it broken up into what we call the standard deviations. Each one of these is one, this would be one standard deviation, so this line right here, one standard deviation away from the middle. This is two standard deviations away from the middle, and this would be three standard deviations away from the middle, and all the data is within 4 standard deviations of the middle. So whether that's above or below, so these numbers are pretty typical numbers that we use. Okay, slightly different. So the slightly different numbers used all the time. So this is 0.15. Usually this is 2.35. So you'll see different numbers being used, which you'll probably see later on in this video. I'll show you. The curve is broken into 8 different pieces, like I said. So how wide each piece is, how spread apart the data is, can be calculated using 2 different ways. You can use the standard deviation formula, or you can use the mean absolute deviation. And they're both going to give you an idea of how far apart, which the reason why these numbers can change depending on which one you're using will determine the width of each one of these deviations. So we have these numbers 3, 4, 5, 6, 7. It's done very easily because 5 we know is in the middle. We know that's the mean because it's literally in the middle of these numbers that are all 1 apart from each other. So when you're doing mean absolute deviation, you would take the average, which is 5, and you would subtract the first number. 5 minus 3 is 2. The absolute value of 2 is 2. And then 5 minus 4, the absolute value of that is 1. The absolute value of that is 0. The absolute value of that is 1. The absolute value of that is 2. 2, 4, 5, 6 divided by 1, 2, 3, 4, 5 numbers. 6 divided by 5 is going to give you your mean absolute deviation. That's your average distance away from the center and for each of those deviations. And then you can do the exact same thing for standard deviation. So the inverse of square rooting something is squaring something. So those are basically going to cancel out. And then you'll notice that these formulas are very, very, very similar in that respect. So it's done exactly the same. Only you're going to use this formula. So you take the average, which is this. 5 minus 3 is 2. 2 squared is 4. And then you do the same thing here. 5 minus 4 is 1. 1 squared is 1. And then when you're done with all that, you do the square root of it, because since you squared everything, you have to do the square root of it at the end. All right, so identify the following 5 images. So this would be normal distribution. This is skewed left, skewed right, and uniform. Hopefully that's been made pretty clear to you by this point. That's a very similar question we had already done, and these are just my pictures that I've done for each one of these questions, and you can see why I chose what I chose, at least, for each one of those examples. Skipping through some of that. So describe the shape of each of the following distributions. So this first one would be uniform. There we go. Normal distribution. I would say this is probably skewed left. This is trimodal, and this would be skewed right, would be the best way to characterize those. What is the approximate mean? Okay, so based on what we did on the warm-up, so the mean, median, mode will all be in the exact middle if it's a normal distribution, so you could choose about that number, 540, give or take. If it's left skewed, just keep in mind that your median is going to be higher than your mean. So your mean's actually going to be somewhere around right here, and the mode's going to be this number right here. So 80-something, something between 80 and 90 is the mode. And I'd say somewhere between 60 and 80 is the mean. For this one, it's 2 peaks. So you know the mean's going to be maybe slightly closer to this one because this one maybe looks a little bit bigger than these pieces. I don't know, somewhere in the middle. And then the mode would be obviously this one right here. Uniform, you know the mean's going to be somewhere in the middle, but the mode is going to be the highest peak, which would be this one, and I think that one's actually slightly less. So these two, whatever that is, 0.7 to 0.8 and 0.1 to 0.2. All right, so we're talking about spread now, how far apart the data is. The spread just tells you how far apart it is, the range goes from here to here, and your standard deviation would be the average distance away from the center. So rank the following from largest to smallest standard deviations. Largest standard deviation would be the one that's the most spread out. That would be this one. And then this would be number 2, this would be number 3, and then this would be number 4 because the data is the closest. So this one's got the smallest standard deviation because the data is closer together. So this basically gets us back to the idea of what I showed in the last video, which means if you take the data and you squish it together, what's going to happen is you're going to have a smaller standard deviation, but it's going to be taller. So if you take this normal distribution and you spread it out, it's going to look like this one. It's going to have a larger standard deviation, but it's going to have a much smaller peak. So it's going to be like smushed down. So its mode would be still in the middle, but it's going to be a lot smaller. Normal distributions, if you just shift it now, if you take that one, if you take this normal distribution and you move it from side to side, its standard deviation is going to stay the same because it's the same width. And the only thing that you're changing is the mean, median, mode. The mean, median, mode are shifting because you're changing the middle of the graph, and that's it. All right, thanks again for watching. Please look forward to the next videos. Have a great day.